back up today then with number 36 that we were looking at yesterday. And we had gone through it two different ways, and we weren't able to get what they had in the solution manual. Yep, and that's what it's supposed to be. Yep, in the solution manual here, they've got 1 minus e x to the 1 minus e minus 1 minus, well, that minus sign is supposed to be an equal sign. It just simplifies down to this. So it's supposed to be an equal sign there. Folks, I went through this 4 different ways yesterday. Second period by free period, I went down with Miss Pollard. She was the AP Calc teacher when I was still in high school here. So I wanted to go down with her and go through it just to make sure I wasn't making any stupid little mistakes along the way. And so we sat down together and we did it algebraically 3 different ways. And then I went on to the calculator just to make sure and took the derivative on the calculator, and it was right. And then as I went back to here, I just realized, well, it's not supposed to be a minus. They've got to type in there. It's supposed to be equals. So they're kind of taking it in 4 steps here, saying dy dx equals the derivative with respect to x of x to the 1 minus e, which equals 1 minus e times x to the 1 minus e minus 1. And then it shouldn't be a minus there. It should be an equals 1 minus e x to the negative e. Okay? So both ways that we had looked at it yesterday in class were correct. We looked at it yesterday with just being a basic power rule, and that was correct. We looked at it with log differentiation. That was correct. The other way I went through and did it yesterday was saying that x to the 1 minus e is equivalent to what? When do you subtract exponents? When you're dividing by like bases. So this would be x to the first divided by x to the e. So the third way I went about and did it was with a quotient rule. Well, the quotient rule, log differentiation, the power rule, they all gave me the same thing. Then I went into the calculator and checked the derivative on the calculator. All of them were the same thing. So then when I went in here, I just realized that's supposed to be an equal. It's not supposed to be a minus there. All right, with 36 then? Good there? Okay, let's go ahead and clear that up. We'll go back onto the main Wikispace page then. Today then is the final day for the 3.9 assignment on page 178. Do we have any last questions off of page 178 before we move on?
Oh, number 45.
Is that the one you had interest in too, 45? Okay, we'll take a look at 45. Directions are: use the technique of log differentiation to find dy dx in 45. And 45's got a lot to it. First of all, folks, kind of going along with the habit we've had all year, do we really, in calculus when we're taking derivatives, do we really want to see roots? What have we always rewrote the roots as? Fractional exponents. So let's look at that first. There's a lot of simplifying down here in 45. Y equals, well, we're taking the 5th root of this whole set, which means this whole set then is going to have to go inside of a parentheses. And a 5th root means we're going to raise to what power? To the 1/5 power. Okay. Well, now we've got 3 factors inside here. Well, all 3 of those factors are going to get raised to the 1/5 power. So this is going to be the quantity of x minus 3 to the 4th. That is getting raised to the 1/5 power. The quantity of x squared plus 1 is getting raised to the 1/5 power. And in the denominator, the quantity of 2x plus 5 cubed is also being raised to the 1/5 power. What do we do with exponents when we're raising power to power? We multiplied the exponent. So x minus 3 is going to be raised to the 4/5. X minus 3 to the 4/5 power times x squared plus 1 to the 1/5 power over 2x plus 5 to the 3/5 power. Okay. Now we'll go ahead, now that we've got it simplified down to there, any questions on what we've got there? Okay, now we'll go ahead and we'll bring in the logarithm. What's the easier logarithm to take derivative of? Natural log. So we'll take the natural log of y and set that equal to the natural log of that whole quantity. Is everybody all right with me doing that instead of the rewrite? Okay. Well, what we've got is now some log properties. What's the main operation going on here with this quantity? Division. Division expands into what with logarithms? Subtraction. So then after we expand that subtraction, we're then going to have a multiplication up here. Well, multiplication expands to what? Addition. So this one log of this whole quantity is really going to expand out to how many natural logs? 3 natural logs. So go ahead and tell me what it would be. The natural log of y would be equal to the natural log of what first? X minus 3 to the 4/5. And now where are we going to be able to put that 4/5? Out in the front. We're going to have a natural log of x squared plus 1. And what are we going to be able to do with the 1/5? Put that out in front. And then we're going to have a natural log of 2x plus 5 to the 3/5. And where are we going to be able to put that 3/5? Out front. Now, what is the sign that's going to connect these two? Plus. What's the sign connecting here? A minus. The plus was from the multiplication, the minus was from the division. All right with what we've done there? Okay, now let's go ahead and do our differentiation then. So really, folks, all the work here was the algebra and the natural log properties to get it to here. Now once we've got this, we're going to find out that that's a pretty basic derivative to go ahead and take. What's going to be the derivative of natural log y? 1 over y dy dx equals 4/5 times. What's going to be the derivative of the natural log of x minus 3? 1 over x minus 3 times the derivative of x minus 3, which is simply 1. Times 1. So I really don't even need to put it in there. I'm going to show it though. Okay, 1/5 times. What's going to be the derivative of natural log x squared plus 1? Times 2x. Good. Minus 3/5 of 1 over 2x plus 5 times 2. Okay. So the actual differentiation process here actually turned out to be quite simple after we did all those properties. So now let's just simplify all of this down. Over here, how are we going to undo this division by y? It's going to multiply by y. So dy dx is going to be equal to y times, over here we're going to get 4 over 5 times x minus 3 plus 2x over 5 times x squared plus 1 minus 6 over 5 times of 2x plus 5. And then do we really want that y there? No. What are we going to turn that y back into? The original that we had at the beginning. Yeah, we're going to turn that back into the original that we had in the beginning. And now it's all just simplifying down again here, folks. I believe in the solution manual they go as far simplifying as they possibly can. Okay, I'm all right with you leaving it as this right here. You know, if we were going to combine these three fractions together, what would we need to get? We would need to get a common denominator, which in this case would be kind of a bear, but we could get a common denominator. They all share a 5. This one over here would need to get multiplied by an x minus 3 and a 2x plus 5. This one by an x squared plus 1 and an x minus 3. We could get a common denominator and combine this all together as one fraction, and then we'd find out that a lot of things would reduce out. But I'm all right with you leaving it as this right here and not going through all of the algebraic simplification of it. Okay. Unless, of course, they said in the directions that they needed it simplified down as far as you could, then we'd want to simplify it. But again, here we're worried about the derivative, not necessarily the algebra and simplifying it all down. Have I answered what you wanted for 45? You going away?
Thank you.
Okay, no problem. Anything else from 178? Okay, so again, today's final day for 178. We'll go from the textbook into the graded homework. Now, yesterday we looked at, what was it, 4 and 7? We looked at 4 and 7 yesterday. Any others we'd like to look at? Number 2. Okay, and again, I told you that you're probably right with your derivative on number 2. You just don't have it simplified down to one of the values that they want for number 2. Was that the case with you last night, Trent? Did you have the correct derivative, but it was just a simplification of getting what they wanted?
Yeah, that was the issue I had with 1 and 2.
Yep.
I couldn't get it to be in the way that they had it.
Yep. Okay. And it's all the algebra, the simplification down here again. So what is the derivative then for arc sine u? 1 over radical 1 minus u squared du dx. Okay, so our u in this case is what? 1 over x to the 5th. Or what would be a better way of saying 1 over x to the 5th? X to the negative 5th. Okay, so dy dx is going to be equal to 1 over square root of 1 minus u is x to the negative 5th squared times du dx. What would be the derivative of x to the negative 5th? Negative 5 x to the negative 6. So I'm going to take that x to the negative 6th and just put it down to the denominator as x to the positive 6. Okay. So we get here negative 5 over x to the 6th radical 1 minus x to the negative 10th. Is that the solution you guys have?
Yes.
That is absolutely correct. It's just not simplified down as far as they would like it. Okay, so now it's just becoming the algebraic process of simplifying this down. Negative 5 over x to the 6th times the square root of 1 minus, how can we rewrite x to the negative 10th? 1 over x to the positive 10th. So let's actually do this subtraction of fractions under our radical. If we're going to subtract those two fractions, we have to have a what? And what would that common denominator be? X to the 10th. So 1 becomes x to the 10th over x to the 10th. Now can I subtract them? Yes, we get negative 5 over x to the 6th times the square root of x to the 10th minus 1 over what? X to the 10th. Yeah, we keep our denominator and we just subtract our numerators. Okay. Well, now we've got a fraction under a radical. And recall, if we have the square root of a over b, it really becomes how many square roots? It's the square root of the top over the square root of the bottom. So in this case here, this is really radical x to the 10th minus 1 over radical x to the 10th. Well, in the denominator there, is that x to the 10th a perfect square? Yeah, what is the square root of x to the 10th? X to the 5th. Negative 5 over x to the 6th root x to the 10th minus 1, and we're now over x to the 5th. And now what will happen with the x to the 6th and the x to the 5th? They'll reduce down, yep. Negative 5 over, what will they reduce down to? X times x to the 10th minus 1, which is then choice, is it C? Choice C. Okay, so up here, if you had this, which I'm sure most of you did, you're absolutely right. You're absolutely right. It's just then the simplification, the algebraic simplification to getting it down to this value right here then. Okay?
So, for number 1, I got down to the derivative. I just don't understand how to simplify that.
How to simplify it down from there. All right, with 2 guys? Okay, so number 1 is going to be a similar concept of simplifying it down. Then number 1, we've got arctangent.
I got the derivative down to 5 over 2 radical x plus 10x radical x.
Okay. Arctangent is the easier of the derivatives. It's just simply 1 over 1 plus u squared. So 1 plus RU is the square root of 5x squared times the derivative of root 5x. Well, root 5x is really 5x to the 1/2. What would be the derivative of that? 1/2 times 5x to the negative 1/2 times 5. Okay, so we would get 1 over 1 plus. What are we going to get right here? What happens when you square a square root? It's just 5x. 1 plus 5x times, as we multiply this one out, we're going to get 5 over 2. 5x to the negative 1/2 is a root 5x in the denominator. So here then we get 5 over, this is a whole quantity here, so it's really got to remain 2 root 5x times 1 plus 5x. And as we look up there, that would then be choice C. Choice C. All right with that then, Danielle?
I think so. I think what I did was I thought of, I don't know what happened there.
I left this one a radical here instead of making it 5x to the 1/2, just because I knew I was going to have to square it. So if I left it as a radical, when you square the radical, they'll just cancel, as opposed to thinking of it as a 1/2 to the 2nd, and then canceling out as a 1. But then over here, the chain rule part for the derivative of 5x to the 1/2 is important as well. So 1/2, 5x to the negative 1/2 times 5. Okay?
That's where I messed up. Thank you.
Okay. Anything else from the graded homework, folks? Now, Trent, you and I looked at one very similar to number 10 then last night when we were looking at that one. Okay. All right, folks, if there's no other questions on that one, we'll go ahead and close that one out. Now, again, graded homework is due today. So then the last thing we've got for today then is the practice exam for Chapter 3. So folks, Monday, your exam is going to fall under 2 categories or 2 parts on Monday. The first part of the exam is just going to be derivative rules. I am going to give you a 1-page sheet that will look similar to the cheat sheet we've got, and I believe there's 10 derivative rules that you're going to have to put down for me. Okay, so there's, I think, a total of, what, I think we came up with 22. The bare bones one just had the 15 because we only had sine and cosine and the 3 arctangents. So the bare bones one just had 15. Okay, well, Monday's exam, I'm going to ask you 10 derivative rules. That's going to be part 1. Okay, so part 1, you're probably going to have about, as soon as you're done with it, but I'm going to cut you off after 10 minutes. I'm not going to let you spend more than 8 to 10 minutes with the derivative rules. Okay, so I'm going to ask you 10 derivative rules. Again, it'll look like the cheat sheet that I showed you yesterday. So it will look similar to this here. It's just going to be the bare bones, so it's going to be the 15. I'm going to put 10 of these 15 rules to have you fill in. And then after you hand that part in, the second part will start with the bare bones cheat sheet. Okay, so the second part of the exam, the actual application part of the exam, I'm going to give you the bare bones cheat sheet. Okay, now the bare bones, again, just has the basic 15. It's going to have sine and cosine, and then the 3 arc ones. It's not going to have all 6 trig and inverse trig ones on it. Okay. And this one's set up very much like the AP exam. You've got multiple choice ones for your basic derivative type ones, and then I think there's 1 or 2 like application type, like velocity type problems, and find the equation of a tangent line, stuff like that. Okay? So first part of the exam is just going to be 10 derivative rules. I'm going to pick off 10 derivative rules out of those basic 15 right there and ask you what the derivative rule is. You'll then hand that part in, and then the second part of the exam, this will be the front page of it. Just the basic 15. And then you'll have multiple choice questions and 1 or 2 short answer ones. Questions at all on the format of Monday's exam? Okay, 2 parts. The first part is just your derivative rules, so know your derivative rules. And then the second part, right now anyways, I'm going to give you the 15 basic derivative rules to use with the exam. And then Wednesday we'll have that first deck quiz as well. Your practice exam, though, here, we've got 15, just some basic derivatives. That's what this whole chapter was all about, were the different derivative rules. So 1 through 15 here goes through the different derivative rules. Power rule, product rule, chain rule, implicit differentiation, log, exponents, derivative, arc sines, tangents, whatever, are all on there. 16 and 17 are finding a second derivative. 18, 19, you're trying to find the equation of a tangent and a normal. 20 has a parametric curve. Find the equation for the line tangent to the parametric curve at t equals 3 pi over 4. Again, how do we find the derivative of a parametric curve? How do we find dy dx with parametric equations? dy dt over dx dt. dy dt over dx dt. 21 then here, we've got a projectile motion type problem. Part A, they want me to find the first and the second derivative. When we've got a position function like we have here in 21, what does the first derivative, ds dt, represent? Velocity. What does the second derivative, d2s over dt squared, represent? Acceleration. What's the third derivative represent? Jerk. How do we find speed? Not velocity, but speed. The absolute value of the first derivative. How long does it reach its maximum height, so on and so forth on those ones. Okay, so I didn't give you any room to perform these ones on here. With the practice exam, I always provide the solutions, and you can see here the solutions are quite lengthy on here, so I didn't want to make the actual practice exam be 4 pages as well by providing you room to do these on, so I just assuming here you'll do these out on a separate sheet of paper and then verify those. Folks, since we have a Monday test, if you would like a review session over the weekend, we will go ahead and do that. The only thing I want to stay away from is Sunday evening. Well, I guess Sunday evening is probably better than Sunday afternoon. The Bills game's blacked out, right? My wife would kill me, though, if I took away Sunday afternoon and left her with all 3 kids by herself. So If you would like a review session Saturday or Sunday evening, I would accommodate that for you. So if you'd like one, throw me a text and we'll get on for, if it's Sunday night, I really don't want to go too long, maybe just an hour tops if you want to get together Sunday night. You guys shoot me a text though, and if you want to get on, I will determine the time and place, and I'll shoot everybody a text to let you know. Okay. John, would you be available at all? Would you be able to get like to a local library or somewhere with internet if you wanted to join?
Probably. I'm not sure.
Okay. I'll do the best I can. Like if we are going to have one, I will shoot you an email as soon as I send everybody a text. So if you can get it in and join us, you're obviously more than welcome to. Okay. Let's go ahead and take a look at a couple of these ones. We haven't done tangent and normal lines in a while. How about we take a look at 19? I want to look at 19 because in order to find the slope, we've got to find the derivative. So what kind of differentiation are we going to have to do here in 19? Implicit differentiation. Let's go ahead and take a look at 19, and we'll find the equation of the tangent and the normal for number 19. 19 was kind of nice, though, because they told us the actual coordinate. We know the x and the y value. Over here in 18, they only told us the x value, so we'd have to plug that through and find the y value. Okay, so ultimately, we need to write the equation of a line. What are the two things we need to write an equation of a line? A slope and a point. We know the point is 1, 2. We need to find the slope. Okay. So how do we find the slope of a curve? We find its derivative. So we need to find dx of x squared plus 2y squared equals 9. And we're going to do that with implicit differentiation. What is the derivative of x squared? 2x. What is the derivative of 2y squared?
4y dy dx.
Good. 4y dy dx. We treat y as if it were an x, and then just tag on the dy dx. That's the chain rule. Y is a function of x. Y is like u. So we just take the derivative as normal and then tag on that dy dx. 9, the derivative would be 0. We want to move the 2x. We want to solve for dy dx. So what would be the procedure in solving for dy dx? What would we first do? Subtract the 2x and then divide by 4y, which would simplify down to what? Negative x over 2y. So dy dx is negative x over 2y. So again, the derivative will tell us our what? Our slope. So if our derivative is that, then therefore our slope at 1, 2 would be equal to negative 1 over 2 times 2. Negative 1/4. Okay. So there's our point and our slope. Our point and our slope. Okay. So part A, the tangent line. Make sure you always include your point slope formula. Y equals times x minus x1 plus y1, where m is going to equal negative 1/4. x1 is going to equal 1, and y1 is going to equal 2. So we get y equals negative 1/4 of x minus 1 plus 2. Need we simplify further? No, and I would recommend you not. Okay, don't lose a point on any basic algebra. Okay, unless they said they specifically wanted it in point slope form or slope intercept form. Okay. Part B, the normal. we don't need to rewrite our point slope formula again. We just need to say what different values we're going to have. Slope is now going to be positive 4. X and Y are going to be the same though, so we get Y equals 4. X minus 1 plus 2. Could we graph really all three things here and see if they're going to be perpendicular to each other and tangent to the curve? Yeah, the only thing we would have to do is we'd have to come up here and solve this for Y. So Y, we would start with subtracting the x squared. We would then divide it by 2. And then to undo the square, we would take the square root. So this would really be how many functions? 2 functions. Y equals the positive square root, and then Y2 would have to be the negative square root. So if we wanted to check this in the calculator, we'd have to do 4Y equals. Y1 and Y2 would be this. Y3 we would put in the tangent, Y4 we would put in the normal, and just verify that we'd probably go to a square zoom viewing window so we could see that they actually looked perpendicular to each other and then tangent at that point. So we could check all of these as well. Questions on 19 at all? How about you guys? Is there one that you're looking at here and saying, well, I'm not really sure how I would start this one? One that you would like to look at?
In 5, we just treat theta like a variable, correct?
Yep, in 5 you've got r and theta, so r would be similar to your y, theta would be similar to your x. Yep. 10 you've got s and t's. 3 you've got s and t's, but yep, it's the same as x and y. At 14 you've got y's and z's instead of y and x. Let's recap again one of the second derivatives. How about we look at 17? 17, we want to find the second derivative for that function. And now again here, in order to do the first derivative in 17, we again have to do what? Implicit differentiation, yep. What would the derivative of y cubed be? 3y squared. Y prime. I'm just going to use y prime here because it'll be, we're going to go find a first and a second derivative, so y prime's a little easier than writing the dy dx. Plus, what's the derivative of y? Just y prime. You know, y prime. What's the derivative of cosine x? Times 2. Negative 2 sine x. Okay, so our first derivative, we would have to factor out our y prime. We'd be left with 3y squared plus what? Plus 1 equals negative 2 sine x. Okay. So our first derivative, dy dx, is equal to negative 2 sine x divided by 3y squared plus 1. Any questions on finding the first derivative? Okay, now, to find the second derivative, a couple things we're going to have to employ again. My derivative is now a quotient. We've got a numerator divided by a denominator, so ultimately we're going to have to use what rule? We're going to have to use quotient rule. But in the quotient rule, we're also, again, going to have to employ what? Implicit differentiation. Yep. So our second derivative, d2y with respect to x squared, our second derivative would be, okay, what is our quotient rule? du prime minus ub prime. Good. Denominator times the derivative of the numerator. So 3y squared plus 1 times the derivative of the numerator. What's the derivative of sine? Cosine. Times negative 2. Negative 2 cosine x. Minus the numerator, negative 2 sine x, times the derivative of the denominator. What would be the derivative of 3y squared.
Y prime.
6y, y prime, plus 0, so we really don't need that in there, over the denominator squared, 3y squared plus 1 squared. Okay. And now it just becomes simplification. And one substitution. What are we going to replace this y prime with? What does y prime represent? The first derivative. Yeah, we are going to substitute that right in there for it. Okay. We don't want the second derivative in terms of the first derivative. We want it still in terms of x and y. So we've got to make that substitution. So as we distribute here, negative 2 cosine x times 3y squared would be negative 6y squared cosine x minus 2 cosine x. Over here, these are just two monomials, so that makes it easier. Negative 2 times 6 would be negative 12, but we're subtracting negative 12. So plus 12y sine x times, and now let's replace that y prime now. Negative 2 sine x over 3y squared plus 1. All over the 3y squared plus 1 squared. Really from here, how much simplification you want to do from there is really be up to you. I'm going to do at least one more thing here. Negative 6y squared cosine x minus 2 cosine x. Over here, this is going to become then again a negative. Negative 24y sine squared x over 3y squared plus 1. And then we're going to, instead of dividing, if you want to say we're going to multiply this all by 1 over 3y squared plus 1 squared, that'd be the same thing. How far have I simplified it down to? What did my solution manual go down? This is 17?
Yes.
Okay, yeah, so I simplified it a lot further than that then. Okay. So we're basically at this point right here. Right there. And again, folks, the amount of simplifying you do really depends on how far you want to go. I mean, unless the directions say in simplest possible form, we want to keep going. But in this case here, I'm fine with where we're at right now. I'm fine with where we're at right now. On a test as well. Okay. Any other questions you see as you're glancing over this, folks? Now, folks, again, it is possible that I've made mistakes on my solution manual, so you know, as you look at it and see it's wrong, and then you go back and do it again and say, no, I'm absolutely right here. There is a possibility that I'm wrong on these ones, and it's very rare that when a class finds a mistake that I go back and change it. So it's very possible that I do have errors on those as well, but just look through them. Again, folks, if you would like a review session over the weekend, send me a text, and I'll shoot a text to everybody else then, and just let them be aware of it. So if you'd like one over the weekend, be glad we will. It would have to be in the evening, though. I couldn't do anything before 7 o'clock on either day. But if you would like one, we could gladly do one. I don't want to have a weekend off with you and not allow you to answer or ask any questions before Friday. Okay? All right. If you guys have no other questions, I've completed what I wanted to go through. So have a great weekend. Again, text me if you would like a review, and I'll send one to everybody else. and we can go through some problems that you've got. Okay? Have a great weekend, folks, and we will see you Monday morning.